Hello, in this video I'm going to talk about the two trigonometric functions, secant and cosecant. These two trigonometric functions, they have many uses, especially in integrals. They make solving integrals much easier, and especially secant, which is used in trigonometric substitution. And you can look at some videos where I use secant to solve integrals using trigonometric substitution. So let's start with secant. Secant, which is abbreviated as SEC, and surely we read it secant of x. What is secant? Secant is defined as 1 over cosine. So it's the reciprocal of cosine. Let's start with the derivative of secant. So secant x prime, I am deriving 1 over cosine prime. So this is deriving 1 over u, which is minus u prime over u squared. But the derivative of cosine is minus sine. So basically, I'm going to get minus sine, which is sine. This is why I will get sine x over cosine squared, which I can write as 1 over cosine multiplied by sine over cosine, which is secant tangent. So the derivative of secant is secant tangent. And so the integral of secant tangent is secant plus a constant c. Now let's check what would be the derivative of tangent. So tangent x prime, tangent is sine over cosine. So I'm deriving here, I'm using the formula u over v, which is u prime v, and the derivative of sine is cosine. So I will get cosine squared minus uv prime, and v prime, the derivative of cosine is minus sine. So I will get minus sine squared, which is plus sine squared, over v squared, which is cosine squared. And cosine squared plus sine squared is 1. So I will get 1 over cosine squared, which is secant squared, because secant is 1 over cosine. So the derivative of tangent is secant squared, which means that the integral of secant squared x dx is tangent x plus a constant c. Now, let's see what is the integral of tangent now. Tangent, as you know, it's sine over cosine. So the integral of tangent is integral of sine over cosine. Now, if we consider that cosine is u, the derivative of cosine is minus sine. So if we put a minus inside the integral, we should put minus outside the integral. So it's as if I'm multiplying by minus 1 inside and minus 1 outside, which is I'm multiplying by 1. So I will get the form integral of u prime over u, which is ln absolute value of u. So I will get minus ln absolute value of cosine, and minus ln absolute value of cosine is ln 1 over cosine, because minus ln a is ln 1 over a, and 1 over cosine is secant, so it is ln absolute value of secant plus a constant c. So the integral of tangent is ln absolute value of secant plus a constant c. Now let's see the integral of secant. Now, to solve integral of secant x dx, we multiply and divide by secant x plus tangent x. So we get secant x, factor of secant x plus tangent x over secant x plus tangent x. And so when we expand the numerator, we get secant squared plus secant tangent. And now also, if we consider that the denominator is u, the derivative, which is u prime, it's secant prime, the derivative of secant, which is secant tangent, plus the derivative of tangent, which is secant squared, which is our numerator. So now I have integral of u prime over u, which is, again, ln absolute value of u, which means the integral of secant is ln absolute value of secant plus tangent plus a constant c. Now the last formula that you should know about secant is that secant squared minus tangent squared is equal to 1. Why? Because secant squared is 1 over cosine squared. Tangent squared is sine squared over cosine squared. So they have a common denominator, which is cosine squared. So this is equal to 1 minus sine squared over cosine squared. And 1 minus sine squared is cosine squared. So we get cosine squared x over cosine squared x, which is 1. So secant squared x minus tangent squared x is equal to 1. Now let's check cosecant. Now, cosecant, which is abbreviated as CSC, so cosecant of x, it's defined as 1 over sine x. Now, I don't know why they called cosecant 1 over sine and not 1 over cosine, and secant, it was 1 over cosine. I don't know why, but cosecant x is 1 over sine x. Now let's check also all the things that we have seen for secant. So let's start with the derivative. I'm gonna go a bit quicker here. So let's start with the derivative. The derivative of cosecant, it's derivative of 1 over sine. So it's minus u prime over u squared, so minus cosine over sine squared, which I can write as minus 1 over sine times cosine over sine, which becomes minus cosecant times cotangent, because cotangent is cosine over sine. So the derivative of cosecant is minus cosecant cotangent, which means the integral of cosecant cotangent dx is minus cosecant x plus a constant c. Now the derivative of cotangent would be cosine over sine prime, which would be u prime v, so minus sine squared minus v prime u minus cosine squared over sine squared, which is minus 1 over sine squared, which is minus cosecant squared. So the derivative of cotangent is minus cosecant squared. And in turn, the integral of cosecant squared would be minus cotangent x plus a constant c. Now, as you can see, the formulas for cosecant are the same as secant, but with cotangent and a negative sign. You can compare them together. They're the same formulas, but instead of tangent, I would have cotangent and a negative sign here. Now, the integral of cotangent, it doesn't have cosecant in it. It's ln sine, okay, because it's the integral of cosine over sine, which is u prime over u, because the derivative of sine is cosine, so it's ln sine. But since I earlier I found that the integral of tangent was ln secant. Here, the integral of cotangent would be ln sine. The integral of cosecant x, so I multiply the numerator and the denominator by cosecant x plus cotangent x. Then I expand, I would get cosecant squared plus cosecant cotangent over cosecant plus cotangent. So if this is u, the derivative would be minus cosecant cotangent minus cosecant squared x, which is minus cosecant squared plus cosecant cotangent. So I will get here, I need a minus sign here. So if I put a negative sign inside the integral, I should put a negative sign outside the integral. And so I get u prime. So now I have minus integral of u prime over u, which is minus ln absolute value of u. So it's minus ln absolute value of cosecant x plus cotangent x plus a constant c. And finally, cosecant squared minus cotangent squared is equal to 1, because 1 over sine squared minus cosine squared over sine squared would be 1 minus cosine squared over sine squared, and 1 minus cosine squared is sine squared, so sine squared x over sine squared x would be equal to 1. If you like my videos, hit the subscribe button at the bottom of this video and like my videos. Thank you for watching.